Okay, looking at the collision problem that we started in class today but didn't finish. I've drawn the picture already. We have a situation where a low mass, that is a 3.33 gram ball, the red ball, with initial velocity of 125 meters per second, I didn't write that in, so I'll write that now, is going to collide with a slow-moving massive ball that is 425 grams and has an initial velocity of 2.25 meters per second, both of them moving to the east. Now I'm using to the right is to the east, so I'm just going to use positives to the right, negatives are to the left. So looking at this problem, I have a collision. It tells me it's elastic. Elastic means that kinetic energy is going to be conserved. So I have two conditions. Number one is momentum will be conserved. And you may be asking, how do I know momentum's conserved? I know from Newton's second law that the change in momentum is equal to the net force multiplied by the time over which that net force is acting. So if I take my system to be these two balls, I've given you no information to suggest that there are any external forces, so we have to assume that the external forces are zero, hence the net force is zero, and so the change in momentum must be zero. So momentum must be conserved. Now momentum is P equals mv. It's a vector, but once again, I'm just going to use to the right as positive. So that means my momentum initial and momentum final must equal each other. So momentum initial is going to be mass 1 v1 initial plus mass 2 v2 initial. And momentum final will be mass 1 v1 final plus mass 2 v2 final. Now, as we did in class, I'm going to rearrange this by moving the mass 1s to the left side of the equation and the mass 2s to the right side of the equation. So I will subtract each of the terms that I have indicated I'm moving here. And so that will give me the relation that m1 v1 initial minus m1 v1 final equals m2 v2 final minus m2 v2 initial. Now, as we like to do, I'll factor out the masses, so mass 1 times v1 initial minus v1 final equals mass 2 times v2 final minus v2 initial. Now that's my equation for conservation of momentum, but note that we had two unknowns. I don't know v1 final and I don't know v2 final. One equation relating these is not going to give me my answer. I need the same number of equations as I have unknowns. So I need to go to a second condition. And the second condition, as I indicated, is going to be, maybe I didn't indicate, kinetic energy conserved. So kinetic energy is 1/2 mass times velocity squared. So setting kinetic energy initial equals kinetic energy final gives me 1/2 mass 1 v1 initial squared plus 1/2 mass 2 v2 initial squared equals 1/2 mass 1 v1 final squared plus 1/2 mass 2 v2 final squared. Just like I did before, I am now going to take the terms and move them so I have mass 1s on the left side and mass 2s on the right side. And so this is going to give me, I will also immediately multiply everything by 2. multiply everything by 2 just gets rid of all those 1/2. So this will give me mass 1 V1 initial squared minus mass 2 V, minus mass 1 V1 final squared equals mass 2 V2 final squared minus mass 2 V2 initial squared. Once again, as done above, factor out the mass 1, V1 initial squared minus V1 final squared equals mass 2 V2 final squared minus V2 initial squared. And now we go one step further and we expand the terms in parentheses. So this is going to give me mass 1 times V1 initial minus V1 final times V1 initial plus V1 final equals mass 2 times V2 final minus V2 initial times V2 final plus V2 initial. Right. If you take this and multiply through using what I have learned to call FOIL, you'd have V1 initial times V1 initial is V1 initial squared. V1 minus V1 final times V1 final is minus V1 final squared. V1 initial times V1 final minus V1 final times V1 initial, those terms add up to 0, so they're equivalent. But now we note that this right here is exactly the same as this right here. And furthermore, this right here is exactly the same as this right here. So that means this and this are equal. If I divide those out, I am left with a simple equation. An equation that says V1 initial plus V1 final equals V2 final plus V2 initial. So now I have two equations that I'm going to use to solve this with two unknowns. I can solve it if I have two equations and two unknowns. So I know both of my initials. I will solve this second simpler equation for one of the finals, substitute it into the first equation, and then eliminate that and solve for the one remaining. So let me start by solving the lower equation for V2 final. So this equation gives me V2 final is equal to V1 initial plus V1 final minus V2 initial. Now I'm going to substitute that equation into my conservation of momentum equation. So I will have, keep that on the screen, M1 times V1 initial minus V1 final equals M2 times, and now for V2 final I put in everything that's above, so V1 initial plus V1 final minus V2 initial minus V2 initial. So this second V2 initial is the V2 initial that I had up here in the original equation. So those are the same V2 initials. This V2 initial here came from that place. Simplifying the right side, I have this. Now I want to find V1 final. I have V1 final on both sides. So I will have to multiply my m's through and then bring the V1 finals over to the right side and move everything else to the left side. So I'm going to have first expanding There I've expanded, and now I need to rearrange things. Now I've got to go to the next page, so I'm just going to copy this and go ahead and go to the next page and paste it. So now doing my rearranging, I'm going to have M1 V1 initial. This one's going to go to the other side. This one comes over, so minus M2 V1 initial. This one here comes over, plus 2 M2 V2 initial equals M2 V1 final plus M1 V1 final. Of course, I can factor out the V1 final on the right hand side, and I have just M1 plus M2. So now looking at the left hand side, notice I have V1 initial with two terms. I have V1 initial times M1 minus M2 plus 2 M2 V2 initial now divide everything by M1 plus M2, and I'm left with my equation for the answer. V1 final is equal to V1 initial times M1 minus M2 plus 2 M2 V2 initial, all divided by M1 plus M2. Now let's put in our numbers. V1 initial was 125 meters per second times M1 3.33 grams minus M2 minus 425 grams plus 2 times, move this over because I did not give myself enough space, times M2 times V2 initial, which was, I forgot how fast it was going, 2.25 meters per second, all divided by 3.33 grams plus 425 grams. Now I'm going to have to quickly calculate this, so getting out my calculator. Sorry about that delay there. But if I did my math right, I get V1 final is equal to minus 118.591 meters per second. Now, I only gave myself 3 significant digits, so to correct significant digits, this is minus 119 meters per second. Now that I have V1 final, the easiest way to get V1 initial is to come back to the equation that I had or to get V2 final, is to use this equation here. So I will copy it, bring it down, and just put in the numbers. That's going to be 125 meters per second plus negative 118.591 meters per second minus V2 initial, which was 2.25 meters per second. And that's equal to, and once again I have to calculate this, 4.15861 meters per second. 4.16 meters per second to my three significant digits. And there we have it. We have the speed of both objects after we have had the collision. Now, does this make sense? Well, I know that the light object is going to have a much bigger change in velocity than the heavy object. The heavy object here increased its speed by a little less than 2 meters per second. The light object increased its speed by, well, changed its speed by over 200 meters per second. That makes sense to me. It's like a BB bouncing off a bowling ball. The numbers seem to make sense. I tend to agree. Now you might say, well, how do you know you're right? Well, you can always check your answer. Say you're on a test, you have 3 hours on the test, you got plenty of time. You can check your answers. I could say my momentum initial was equal to m1 v1 initial plus m2 v2 initial. So that's going to be 3.33 grams times 125 meters per second plus 425 grams times 2.25 meters per second. Well, if you multiply that through, you have 1372.5 grams times meters per second. Now my momentum final, for comparison, is m1 v1 final plus m2 v2 final. That's equal to 3.33 grams times minus 118.591 meters per second plus 425 grams times 4.16 meters per second. And so, putting that into my calculator, I have again 1372.5 grams times meters per second. So I've shown now that momentum was conserved with those calculations. At this point, I'm satisfied. I'm not even going to go and do the kinetic energy calculations. I'm sure that's conserved too. So there you have it.